And that's pretty much everything I've got for you on this. We'll just go through an exam style question now, just to cover a few of those things again, to give you a chance to have a go at one. So we've got the distance a bee is from its hive, and I've given you an expression for it. Just a hint, I've given you the expression with t factorized out. Multiply that all out before you do any differentiating or integrating. It will just make it easier and stop you making mistakes with your differentiation. We want to find the distance the bee is from its hive. So that's the displacement. We already have an expression for the displacement, so you basically just need to sub in t. Find the times at which the bee is stationary. What does stationary mean? It means the velocity is 0. Okay, so you want to find the times at which the velocity is 0. And show the bee reaches its maximum speed after 2 minutes. Notice that the time's in minutes here. If it reaches its maximum speed, that means the acceleration must be 0. Okay, because if it's reached its maximum speed, it must have just finished accelerating and be about to decelerate. Okay, so its acceleration must be 0. So I've given you a few hints there for each part. Have a go at this question now if you've got time. The last bit is pretty tricky. B is a little bit tricky as well. Certainly have a go at A. That one's not too tricky to do if you've understood the majority of the content. So have a little go at that now, and we'll go through the answers when you're finished. Okay, hopefully you've had a chance to have a look through those and have a think about how you would answer them, and hopefully got some answers too. So let's go through them quickly. The first thing I'm going to do is I'm going to multiply out the expression for t. To be honest, I've put that in there to trick you a little bit. They often do this in exams, factorising out t. Just multiply it out to start with so you don't get confused. It looks like that, all multiplied out. So for part A, you want to find the distance of the bee from the hive at t is 5. All we do is substitute it in. S is the displacement from the hive. So I just substitute in my t is 5. And put it in a calculator. That gets me 6.67 meters. So they don't go very far. Okay, so maximum displacement at t is not the maximum displacement. Sorry, just the displacement at 5 minutes is only 6.67 meters. Part B, you want to find the times at which the bee is stationary. Remember, this means if it's stationary, the velocity must be 0. So I need to find an expression for the velocity. Remember, to get from displacement to velocity, I need to differentiate. Okay, so V is the displacement differentiated. So I'm going to differentiate our expression. That's going to give me t squared minus 4t plus 3. Okay, now I want to find the times at which the velocity is 0. So I set that to 0. And you can hopefully see this is a quadratic. Since it's a quadratic, I can actually factorize this one. It's quite an easy one to factorize. It's going to be t minus 3, t minus 1. So the solutions are 3 and 1. So the times at which the bee is stationary, so it's stationary at 1 minute and 3 minutes. Stationary at 1 minute and 3 minutes, okay, just by solving that quadratic and setting v equals 0. For part C, we want to show that the bee reaches its maximum speed after 2 minutes. Remember, maximum speed, we're looking for the acceleration to be 0. Okay, so I need an expression for the acceleration. The acceleration is the velocity differentiated. Okay, it goes from velocity to acceleration. I need to differentiate. So I've already got an expression for the velocity because we worked it out for part B. We found that was t squared minus 4t plus 3. I differentiate that to find acceleration. So if I differentiate, I get 2t minus 4, and 3 disappears. And we've said the acceleration is equal to 0, so I can set that all to 0. So my equation now says 2t minus 4 equals 0, and the solution to that is t equals 2 minutes, as the question says. Okay, so I've proved there that at t is 2 minutes, the acceleration is 0, which means it must be at its maximum or possibly its minimum speed. Okay, but it's maximum in this case. Okay, so hopefully those answers made some sense to you. They're certainly not the easiest ones in the world. They're pretty much getting towards exam standard, those questions. Gives you an introduction of what kind of difficulty you might be expecting in the exam. But just mainly try and remember the order we go in. When we differentiate, we go from displacement to velocity to acceleration. When we integrate, we go back again. We go from acceleration to velocity to displacement, and we need integration constants when we go that way. And that's all I've got for you on kinematics and calculus. So in the meantime, have a look at the website at Solve4x. We've got loads of other stuff for you to have a look at on this topic. Loads of problem papers to work through with fully worked solutions and videos that go through the solutions as well. Also some old exam questions you can have a look at to see if you can handle the exam style questions. But next time we'll be moving on to forces, which is the last topic in this entire module. There's just a couple of lessons on that one to go through how forces fit together with accelerations and dealing with pulleys and problems we get based around pulleys on exam papers. So thanks very much for watching this video, and I'll see you next time.